Pink and green. Lūdzu, jums stāv pie durvīm vai šeit, izvēlēties vietiņu. Tu droši vari, mums ir ļoti daudz laika, tā kā tu droši vari runāt, jā.
Hello everyone. We were just in the forest together with my colleagues. They are here. Robert is one of them. Jutta and others are on the back. And today we are going to talk about the bryophytes or the mosses in more common name or sunas in Latvia. And we are trying to cultivate in Latvia for the first time in such measures. But after all, the mosses have been together with the civilization as long as we remember us, because if today we grow our pot plants and different edible plants in peat or the dead mosses, then even earlier the peat was a question of survival, because they used it for heating their homes, because in the countries where there is no wood or coal, they use peat for heating. And so you can say that mosses have helped us to survive for many centuries already. And not only that, but I think all of you know the moss roofs, and some of examples are here from our Ārēši settlements in late near Cēsis city. This is also from 9th to 10th century, such small houses, and they have moss roofs. And it's about two reasons for this. One is in winter time it protects from cold, but in summer it can stop a possible attack with the burning arrows, for example, because the mosses are most of the time moist inside, so it can prevent from burning. And you can see such homes also in other parts of the Europe, in Iceland, for example. And the same reason in cold areas, the mosses help to protect from rainwater and cold. And if you go to the warmer areas, you can see them growing everywhere, because they actually like it to grow, even when you don't want them to grow there. Such examples are in Italy or in Japan. If you know the Kokedera moss temple, maybe you have heard about it. Some people think that they have planted the moss there, but actually no. It was very, very ancient temple, but it was again destroyed and burned and so. And the mosses have just started to live there. Now it looks like a small, beautiful green, like a fairy tale. But they choose this place, so they go there. And also in Italy, it was a very nice villa d'este. It's Renaissance buildings with a beautiful garden. And the mosses are there because they just like it. And so we try to combine these properties and want to grow. And here I listed some of the properties of bryophytes. As I mentioned, the rainwater stopping, roofing material, and it also helps to collect the pollution from air. And if we go to more urban sites and the cities, one of the main reasons for bryophytes is improving the air quality, reducing noise, and we just like them because they're aesthetic, beautiful, and they can grow to almost anything. They are evergreen all year, and one of the nicest is they are poikilohydric plants. If you know such plant, poikilohydric, it's they react as the environment. If the environment is moist, then the plant is moist. If the environment is dry, then the plant is also dry, but it can go back to survival. And it's very good to use these conditions. And more about the pollution, we use this drawing to represent our planet activity, which is most barrier in the city to protect our citizens from pollution that comes from the traffic. And we want to use such panels that are overgrown by graphite near the streets. Here is a park, and there is a pretty large road in the Riga city, in the center. And the idea is that these moss walls will protect from the noise and the pollution. And we will use a solar panel that was used before but not working anymore. Grow the moss and protect with a metal mesh. We have already tried and tested 4 different materials where to grow them. It's geotextile, hemp, jute, and cotton. And we used 5 different species so far, but today we were to the forest and we collected 1 more. So it's still in the process to select which species are the best. But we have already some results that actually the best is the mixture of different species, not only one. And from the different materials, the result shows that the best is the hemp fabric. It collects the water and holds it more longer than for example the gel textile, and the structure is more suitable for the graphite rhizoids to attach than for example the jute. Whereas the cotton is just bad. Yeah, it looks good, but it's really bad. And our colleague Roberts was helping with the growing activity, and I can't even tell you what specific conditions were in the lab, but we used some lamps and sprinkles for the watering, and the boxes were covered with such for some periods because they are rather sensitive to the dry. So we need to keep them moist all the time, and the temperature was constant, and the results showed that they really like to grow there. We used it for 75 days in the lab, and we see the increased shoot size very well, and we tested different materials what to add to the water to see what works best, and Roberts will tell you more if you have some questions about it. So now they are in open air. It looks so good, of course, but also not that bad as we expected because it's almost a full month and they are still alive. So it's good because the weather was rather bad in Latvia for 2 weeks when we started to grow them outside, and then it was too moist and they are struggling, but we'll see. This is the next step to test them more in the outside, in the botanical garden. And our results are published already in 2 papers, and you can read them, or if you have any questions, just please come and ask my colleagues. And we are very grateful to our funding and from different funds. That's it.
Thank you. Are there any questions?
Were the results also different between the different species of moths, or were they pretty much the same on the same substrate?
Yeah, we collect them from the same forest type, so we expect that they have the same racebus,
Yeah.
yeah, and so they react similar to the same factors.
I have a question as well. Gardeners always fight with mosses in the lawns. They think that only grass could be the good and qualified as greenery around the home. Do you have some, what do you think about this? And maybe it's possible to start to change somehow their mind.
Yeah, exactly. It's a mindset. You have to change the view to the law, because if you have more moss in the garden, you actually need to work less. So why not use it? Because it's green all year long and it looks good. You don't need to mow. So yeah, but it's a really personal view how to look at that.
And maybe you have some experiments, what is more sustainable or healthy, moss or grass?
No, I haven't. I just know that some people try to rake or how was it?
Yeah,
Yeah, and it doesn't work at all. So
Mm.
yeah, just
Thank you very much.
Yes, any more questions, maybe? No, if not, then thank you very much. Yes, so our next speaker is Kristaps Kundrats. Tagad būtiņas puslaidī.
Hello, everyone. My name is Kristaps Kundrats, and I'm representing University of Latvia Botanical Garden. And today I want to tell you about our latest project we're working on right now. And usually, every gardener knows what the greenhouse is, and everyone tries to grow something in there. But when we talk about greenhouses, don't talk about energy efficiency, because you know how quickly heat leaves the greenhouse. But is it always the case? So our goal is to create a farmhouse that is sustainable solutions for not only the plants and people, but for our planet. About the history of ours, University of Latvia was founded in 1922. At the beginning, we were located on the other side of our capital city, Riga. But in 1926, we were moved. We went to our location where we located right now, Gandalf 2. And 2 years later, Professor Nikolai Smalta, director at the time, started building the farmhouse. And at the beginning, farmhouse looked like this. It was 9 meters tall. But as you can imagine, when you want to grow trees in the farmhouse, they tend to grow very big, and 9 meters can not be enough. So later, in 1953, the farmhouse was raised 3 meters up. So trees had 3 meters more to grow. But as you can imagine, ficus, palm trees, araucaries, and other trees, 12 meters is not enough. So in 1972, farmhouse reached 24 meters, becoming the highest farmhouse in Baltic states. But time flies, and even the big greenhouse reached the critical condition. What happened? The structures were unsafe. Inside pathways were damaged. Big trees, roots were lifting up the pathways. So we had to do something about it. Sounds easy enough, but is it easy? Because many challenges were there. And thanks to Thermalot, the only company who was brave enough to take the task to rebuild the farmhouse, we started work on 2024. But the fact that it's the highest farmhouse in Baltic states didn't help. The location in botanical garden didn't help because every plant bed around is something very important, even the smallest plant. So they had to get machinery, which is made to work on a very high greenhouse, and also working inside was a challenge as well. So they bought this construction lift, especially for this project. The plan for this lift was that it presses as little as possible the weight on the roots in the greenhouse. Also, working together with plants which can be transported out is a big challenge. And that was the reason why only Thermalots was brave enough to do that. And the construction was planned to go for start at 2024 and finish in the same year, October. Unfortunately, as it usually does happen, construction was longer. It is still happening. So we had to think about heating the plants in the colder weather as well. But anyway, the construction started, and as always, we start with a foundation. Every foundation was restored and created new. And then we went to the load-bearing structures. And as a surprise to us, it wasn't as simple to clean them, the old paint, because it was really tough paint. The company tried 4 different sanding machines and ended up with the most powerful one to take off the old color and the old paint. And that was the reason why it took so long to renovate it. You can see a person working approximately at 14 meters high height, and it was really, really terrible. Sanding next to the plants is very tough because all the sand goes around, all the paint bits flies around, and they land on the plants. And if they land on palm trees, they get stuck in there, and it's really difficult to clean that out. We had to, the main load structures stayed there. They were recolored because they were strong enough, but we changed also the walls. The new polycarbonated walls were installed, and also that was a challenge because it's 24 meters. But difference from the previous cover was that on the roof we didn't put polycarbonate, but we put glass. And reason for that is we are collecting rainwater now and to water the plants. And during the winter, glass will help us to melt down the snow, collect it, and also use in watering. But to become energy efficient, we had to have a special system for that. And in these screenshots of my phone, you can see that I can see what's happening in the greenhouse at any time of the day from any place. Well, I have an internet connection, of course. And on the top of the roof, we have weather station, which shows the temperature, wind speed, also the humidity outside. And then, of course, we can see the temperature inside, humidity, heating, and that all can be controlled from your phone. Also, you can control it from the technical room with this machine, and we have also a program on computer where you can collect data to start working with it to make it more energy efficient. The heating system had to be replaced because we had to have these modern valves that send the information that can be controlled remotely. So that was reinstalled. All the pipes in the greenhouse were also reinstalled. And a new thing to our farmhouse was shading screens. People usually know shading screens from as protectors from bright sun. And they actually do, they protect approximately 50% of the sun. But not only that, they also protect the heat inside the greenhouse during the cold months. We don't have data yet because it was installed in spring, but this winter we will start collecting data and test how much heat they can withstand inside the greenhouse. The instruction of the said 70% of the heat. 70% is huge number to for energy efficiency. Also, because it's 24 meters high, we had to make sure the air flows evenly. So it's not like usually it was up in the top of the farmhouse, approximately 40-45 degrees during the summer. And how we know it, because we had arborists who would get up there, cut the trees, and they would tell us how hot it is up there. And when on the ground there is approximately 25-30 degrees. So the turbines will even the air so we can work with it. Also, ventilation windows, we have big, large 4 windows, 2 on east side and 2 on west side, which will help us to let the heat out when it's too much. What we didn't foretell was that in our garden, there's a hawk who is catching other birds, smaller birds. And the smaller birds were trying to find a place where to hide from this big bird. So what happened this year, we've noticed is that the birds are coming inside through the ventilation windows and hiding in the greenhouse. The problem is, during the day, the windows are open, they get in, but during the evening, they close slowly and they can't get out anymore. So we have to work with this problem as well. And also, it's really hard to see, but by the turbines, there is a irrigation system as well, which is not just a simple irrigation system, but it's more for misting to create humidity in the greenhouse. And that's gonna work, and it's gonna be also something new that we have never had or used. So at the end, the goal was to create this greenhouse which provides ideal conditions for these exotic and endangered plants. Also create a really nice, efficient workplace for employees and also for visitors so they can learn about biodiversity. And maybe even the most important thing is to reduce environmental impact, which means that in all times we would have to heat up the greenhouse, but we would keep the windows open and the heat would go out and we would not work very smart. Now we have this system that will help us to provide more energy efficient ways to work with it. So more or less, that's it. I'm open for questions.
When it's going to be finished for the when will they finish and it will be available for people to visit?
Yeah, this is a question I've been receiving since last year, October. And now we see this finish line. We're gonna be there soon. My hope at the end of the summer, we will be there. Right now, we're learning how to control the programs. Some little tasks inside need to be done. Surrounding area needs to be taken care of, but the main construction works are done. So anytime soon, but my guess would be end of the summer.
Yeah, okay.
Aren't you afraid of the insects that are coming from the outside to the greenhouse? Yes.
Not all insects are bad, some are
No,
pollinators.
some are good, but I know that some are like,
This is-
I've been there in my practice and I
Yeah.
remember when how I worked there, while
Yeah.
it was still closed. And it was always like,
Yeah,
The same as with birds, they can easily find the right eating, but when you
they don't wanna go out. Of course. My experience working with plants, I've noticed that the healthier plant is, the less insects will attack it. And creating ideal conditions for them, we're working towards making them safer, less vulnerable against the insects. But insects will be always there. We can't eliminate them totally. What we can do, we can make a volunteer group. Maybe which I've heard in Sydney, they have this, where people come and help us to fight with the insects, squish them with fingers even.
so no, you won't have some mesh in these windows that are opening to protect the, like, to not let the small birds in and also the insects.
We are thinking about it. This is something we didn't think at all about, but we'll take a look and see what we can do, because the system that opens and closes, there are some things that are moving, and that's why we can't cover it totally, but also putting very small net there to like keep something out is also blocking the airflow inside, so we need to think about that.
But in our greenhouse, there are birds as well, they even make nests,
And
but they just live there, there are plenty of insects sleep, so they.
we have nothing against the birds because they can live there and we're not against them. The problem is that sometimes they can't get out. And if they can't get out, we need to make sure they have something to drink at least there, because in the hot summer days, it can be quite hot in there.
They will be insects.
Yeah, hopefully.
And how old is the oldest tree in your greenhouse?
More than 100 years.
It's from the beginning.
Yeah,
And
it was-
how high is it?
it's the top of the roof.
Top of the now. Yeah.
Every year, every autumn, we call arborists that cuts the trees and forms them. That's a challenge.
And which one it is?
Because
Because the most is the
I have a question about weather station.
Yeah.
Is it check, solar, influence? How much solar?
the company that was installing it said that there is an option of that,
Hmm?
but we need some studying to understand it. Just the numbers won't help us. We need to understand how to work with those numbers and how to do.
Of
But
course, yeah.
for programming the shading screens, that's an aspect that
It
will be
is,
looked
it's
at.
here, because it will be very interesting for future projects. Because to check what's happening inside and outdoors and
Yeah.
how it's
The-
influence, and maybe I didn't catch, do you have extra lighting?
About extra lighting. The company that was renovating that is renovating the farmhouse, they came with this idea, we will provide you with a special lighting for the plants. My question was why? Why would you do that? We have, once a year, we have to cut the trees. Install a special lighting for them to grow better, we will have to do it twice a year. So they said that the new lamps we are having, they are dimmable. And you can control the spectrum so that trees would not grow as fast. Like stop them a bit.
Nice.
That will be in the future to be tested. Some lights are on the very top of the greenhouse, but lighting mostly was for the visitors, so they can easily travel there, and of course employees to work efficiently.
I think what it will be interesting not only for visitors, but for lower plants, because under the big trees, where always are shade, and flowering plants not flower because it's not enough light.
Exactly.
So I think it will be very good idea to push different types, bougainvilleas and etc. to bloom.
Yes, exactly. That's why we pushed less lights on the top and more lights on the middle, because on the top, everything is covered by the big
Yeah.
trees anyway.
And do you think about how many hours you will light in the winter?
Yeah, that's what we're now programming and thinking about, but it's like a problem for winter. So right now we're concentrating on the summer problems, which are plenty enough. But yeah, end of the summer, probably we will start thinking about that as well.
And will the next problem about like there's a special
Light pollution, yeah.
light pollution, so you will check as your screens are thick enough to not put the light.
Outside, exactly, yes. But the lamps are, you can see them here.
And are these LED lamps?
LED lamps, of course, yeah, efficient.
RGB, carbon,
Uh,
UV.
they have all the specters.
Yeah.
And as the renovating team said to us, these lamps are 95% efficient. So it's not that in 2 or 5 years there will be more efficient light lamps. They are almost at the
Best.
goal, yeah.
Wonderful.
Okay, if there's not any more questions, then yes, thank you very much for. Latvia, Ukraine, and Romania, netiek, yeah. Okay, then I would like to welcome the last speaker of today from Uzbekistan, Iskandarov. Is this the word?
This is.
Yeah. Yeah, so here are the buttons to change the slides.
Oh. Good morning, dear professors and participants. We came from Uzbekistan. We are studying in Samarkand Agri Innovations and Research University. Our team members is Dilmiral, Salahuddin, Nurgul Masoy. Let's start our presentation. Currently, the agricultural sector is a rapidly development sector. Also, a large part of the agricultural sector in Uzbekistan is based on mineral labor as a result, limited resources, such as water and mineral fertilizers are wasted. This in turn has a negative impact on the ecology in soil. Fertility on the productivity of the crop. Our project goals create a digital application that can measure the level of fertilizer in the soil and the field, analyze the moisture level in the soil using a sensor, notify the farmers mobile device of how much fertilizer to apply to the field and the wind and how much water to apply.
The main tasks of our project, farmers should know exactly how much water is needed, which part of the land, and what time. Companies should deliver more products to people and cause less harm to nature, which means using every inch of land efficiently. Fertilizers should be used only where necessary. Cultivations of clean ecological products and reducing salinity levels by 15-20%, saving 20-30% of the amount of water using by uses water resources wisely.
In agriculture on farmers, it's possible to control the cultivated areas with helping of sensors by installing sensors at certain distances. In the fields, we can monitor soil moisture, the amount of fertilizer, and all the indicators through the farmer's mobile phone. The special device predicts the data received from wireless network and sends the time and amount of water and fertilizer to the farmer's mobile phone through a special application. This device restores the data through a dedicated wireless network that is partial everywhere on Earth. Cost estimated. Ground contact sensor, circuit board, main control device.
Any questions? Have you done already some kind of data gathering and data analysis, like or the prototype of the machine? So you already. Maybe you can show to everybody.
Fertility, moisture, pH, temperature, sunlight, humidity.
Okay.
It's pressure.
We can pass it around maybe. I'll speed it. So, and so as I understand correctly, you want to have multiple of these sensors. Yeah.
If there is 5 for sensors.
Yeah.
How much, I'm sorry, how much big field, how many sensors you need?
Hectare, 5
It will be enough, yeah. And how do you proceed the data to the mobile phones?
Mobile phones, internet, on time,
Real time.
and farmers mobile phone. Mobile phone sends to control special application.
What about data recording? Can I see the data from the day before or from a week ago, how my field was, or does it show only the real-time data? The history of data, can I see a couple of days back? What was there going on?
History, that is writing, saved. Okay.
But I have a question. Isn't understand, but for example, for one plant, there is needed watering 1%, and for a different one, different percentage. How does it know this different watering and fertilizers? Okay.
Oh, any more questions? If not, then thank you very much. And yes, that will be the last of today. So we have successfully ended the presentation part. So I will give the last remarks, the last words to Antas Parinska.
Thank you very much. I really enjoyed today. I hope all participants here and online as well find something interesting to heard about. And as part conference, I hope we will meet next following years as well with the new insights. And it's very nice, but it doesn't depend from which part of world or countries we are. We thinking about same more about propagation of quality potatoes or how to take care of plants, find new sensors and ideas to save energy. So these our main goals in this years, and I'm happy to do the best part because I have certificates for all speakers which today we heard. And so if somebody didn't get one, please ask me and we find out, because I'm afraid, but not all people was in the list who present in the last presentation, but others must be here. So thank you, Otto Beck, Camiliano, for your presentation. Thank you very much. Onward, waiting at home, Iskandarov. Kristaps Kundrats, lūdzu. Tur var redzēt nevis āju gluti, bet internetu. Kāds virs. Līdz rasdiņam. Paldies, Lidija Vajavoda. Monira?
Monira is online.
Oh, yeah, of course, so you will give her. Robert Strumiņš, thank you very much. Hard part was yours. Ramado Sabrina. Yeah, thank you very much for that presentation. Well, and that's it. So, sorry, I don't call online guys. We will send electronically certifications for them. So, thank you very much for great day and enjoy.